Hi guys, welcome to Simplified RSA, the guys who makes it looks easy. I'm Mr. Maimane, Nivuyile Foot. So today our main topic of focus is quadratic functions. We have the so-called quadratic formula, and a lot of people have been using the quadratic formula. For those who don't know the quadratic formula, this is how the quadratic formula looks like. This is how the whole story starts, right? So we have a quadratic function can be represented as y is equals to ax squared plus bx plus c. I normally tell students that y is the same as f of x. So meaning this could be represented as f of x is equals to ax squared plus bx plus c. Y and f of x is the same thing. Function of x, or you can just use y as a variable. So you just have to remember that these two things represent the same thing. And then we get to a point where they say the solution for this is minus b plus or minus square root of b squared minus 4ac all over 2a. This is what we know. So the solution for these two, or the solution for this, which is the same thing, is actually one thing. The solution for a quadratic function is this for the x-axis. So to solve the x part of a quadratic function, we use this formula. But how did we come to this? Which is a great question. Like, how do we get to a point where we use this quadratic formula to solve the quadratic function? So now I'm going to introduce you to the so-called completing a square, right? Let's try it. So now this is the standard form for quadratic functions. We know that to get the x-intercept, you must let f of x to be 0. And to get f of x, you must let x to be 0. So f of 0 gives you the value of x. So for now, letting f of x to be 0, this will result as ax squared plus bx plus c is equals to 0. I'm just going to write this here properly. So it becomes ax squared plus bx plus c is equals to 0. The next step, I'm going to complete the square to solve for x. I'm going to solve for x here. I'm going to solve for x of this quadratic function when is equals to 0 using completing a square rule. So to complete the square, the first thing I need to do is to remove a, such that I must divide by a throughout. Therefore, if I divide by a throughout, I will have x squared plus b over ax plus c over a is equals to 0 divided by a, it's 0. So I will have this. The next step of completing a square is I must add and subtract the square of half the coefficient of x. I must add and in this equation, I must add and subtract the square of half the coefficient of x. Now, getting a half of anything working sharp, the coefficient of x is b over a, right? The coefficient of x is b over a, not this x squared, x, because this x squared, the first thing I did, I just removed a and then I have it like that. So now, if I have to square half the coefficient of x, the coefficient of x is b over a. To get half of everything, you just have to multiply it by half, 1 over 2. That's how you get half of anything. So half of the coefficient of x is going to be b over a times half. So 1 times b is b over 2a. So this is the coefficient. This is half the coefficient of x. But then half the coefficient of x, I have to square it. I have to square it. After I square it, and then I will add and subtract the square of half of that in this equation. And if you check, whenever I say b over 2a squared minus b over 2a squared, this is equals to 0. Just like I haven't done anything. Hence, we are just manipulating the equation, but then it's like we are adding a 0 to this equation, but in this form, because 0 can be represented in many different ways, right? So let's go and add and subtract half the square of the coefficient of x here. So we'll have then x squared plus b over a x, and then I add the square of half the coefficient of x, and then I again subtract it. So it looks like I just added a 0 because this part here should give me a 0 indeed. Therefore, this is the same as plus c over a, which is that part here, then is equals to 0. So this is how I add and subtract half that. Furthermore, now I can simplify this part from the other side of the equation. So here, I can arrange this like this. X squared plus b over ax plus b over 2a squared. This one is equals to, I'm going to take this to the other side of the equation because I only want to complete the square on this part that involves x, and I'm going to factorize this part here. So taking this to the other side, I'll have b squared all over 4a squared because it's squared there. So b squared all over 4a squared minus c over a, because this one was a positive, it has to be negative here. This one was a negative, it has to be positive there. And then, furthermore, this is how I complete the square. By completing a square, we say that I take this x, I take the value of x, I take the sign of the coefficient of x, this one. So from x squared, it's x. I know that to get the values of x squared is x times x. So I take x, I take the coefficient of I take the sign of the coefficient of the second x, and then that's going to be a positive because it's a plus. If it was a minus here, I was going to take a minus. And then I take what is inside the square. I only take what is inside the square. The reason why is because I will square this thing after. That is completing a square. Because squaring this, it means the square represents the square for this part. The square also represents the square for this part, but then this part here, you can get it from here. I swear to God, if you can take this part and then you simplify it, it will take you back to this because it's completing a square. And then now, simplifying this other part here, we have 4a squared as our lowest common denominator. 4a squared divided by 4a squared, it goes once. 1 times b is b squared minus this negative. A times, I mean, 4a squared divided by a goes 4a into 4a squared. Therefore, we'll have 4a times c is going to be minus 4ac. Therefore, we are here now, right? From here, just to create space, I can just move this here. So now, because of space, we're going to move this from here to there, right? Just to create space. So I can get rid of this. To solve, remember the whole point is to solve for x, and I have a square here. So I can just put a square root here and the square root there. Therefore, this will come out as x plus b over 2a because we just removed the square there. This is going to be equals to, now we have the bottom part and the up part. Oh no. This has to be 4a squared from the previous one. So we have the top part and the bottom part. The top part is 4a squared. Already we know that 4a squared, we all know that the square root of 4a squared is the same as 2a. Hence, I made a mistake by writing 2a in it because I know the outcomes already. So here, the top part can be solved. So the top part will be plus or minus square root of b squared minus 4ac. And the bottom part will be over 2a because 4a squared, the square root of 4a squared is the same as 2a. But the top part, because it's a compound there, we can't simplify this. So therefore, this is what we have. Since I'm solving for x, if I take b over 2a to the other side of the equation, I'll have x is equals to minus b over 2a plus or minus square root of b squared minus 4ac all over 2a. Now, you can see where this is going. We have denominator of 2a, denominator of 2a, meaning we can write this as 2a goes once there. 1 times minus b is going to be minus b. 2a goes once there times what we have up there, which is plus or minus square root of b squared minus 4ac. This is how the quadratic function comes about. This is how we get our quadratic function. So this is how we get our quadratic formula from the quadratic function. Hence, we say this is the solution for the quadratic function. So let me put it like this again. We say when you have ax squared plus bx plus c is equals to 0. We say the solution to this quadratic function is this. So ideally, ax squared plus bx plus c can be written in something of these forms. Is equals to 0. Suppose we have x squared minus x minus 6 is equals to 0, right? From here, anyone can see that the value of a is equals to 1, because from this, the value of a is 1. The value of b, which is attached to x, it's going to be minus 1, because we can see that what is attached to x is a negative number, and the value of c is minus 6. So to factorize this, or to get the values of x here, you can just go directly and substitute from the quadratic formula. You will get the exact values for this. How so? You're just going to go to your calculator. You're just going to go to your formula and substitute the values. So for b, we'll have minus 1 plus or minus square root of b is minus 1 squared minus 4. A is 1. C is minus 6. All over 2, 1 for a, according to the formula when you substitute everything like that. And then this is going to be summarized as negative times negative 1. It's going to be 1 plus or minus square root of, inside here we have 1 squared. So let me just simplify this aside here. We have 1 squared, which is 1. We have minus 4 times 1 times minus 6. Minus 4 times 1 times minus 6 is going to give us positive 24. Therefore, 1 plus 24 is going to give us 25. So it's to the square root of 25 over 2. So as you can see here, we have two parts. We have one part that consists of a plus. We have one part that consists of a minus. And we know that square root of 25 is 5. Summarizing this further, I will have then 1 plus or minus 5 over 2. As you can see now, I should have two values for x. One value for the positive part, one value for the negative part. So 1 plus 5 over 2 will be my x value, or 1 minus 5 over 2, x will be equals to that. So 1 minus 5 over 2 is minus 4 over 2, which results in minus 2. So x is minus 2, or 1 plus 5 is 6. 6 over 2. 6 over 2 is just going to be 3. So my values is going to be x is either minus 2 or 3. However, if you don't, so now we show that x is equals to minus 2 or x is equals to 3. However, someone who knows how to factorize could have just went straight from here and get the factors of the whole thing by saying, okay, sharp, to get x squared, I can multiply x and x. To get 6, I can multiply 3 and 2, but the 6 has to be negative, meaning 1 has to be a negative number, 1 has to be a positive number. Looking at the coefficient of x, which is a negative number, it means the bigger one, I'll give it a negative, and then this is going to be a positive. And then solving this now would be x plus 2 is equals to 0, or x minus 3 is equals to 0. This is going to result as x is equals to minus 2, or x is equals to 3, which is the very same values that we get when we use the quadratic function. So now that we understand the birth of the quadratic formula, that was an introduction to the so-called completing a square. Now that we know how to complete a square, let's move on to discuss the nature of a quadratic functions, how it works, how the shape of the graph is going to look like, and all the factors that are involved. For today, I'm gonna cut here because I don't wanna make longer videos. You have to stay tuned for the next video. I'm Mr. Maimane. This is Simplified RSA, the guys who makes it looks easy. So please don't forget to subscribe to our YouTube channel, follow us on Facebook, follow us on X, follow us on Instagram, as well as on TikTok. And also at this point, you can also access our learning channel through Spotify. So just go to Spotify and search for learning channel or simplified_RSA, and then you will have the content that we providing.